I'm Ed Shimon, one of the senior meteorologists over at the weather office in Lincoln. I've been in the Weather Service since November of '94. So I've been doing this quite a long time, although spotter training really wasn't as big right when I got in, but I've done quite a few spotter talks. We try and shift them up. Any new spotters tonight? I think we probably have a few. Yeah, okay, great. Thanks for coming. And obviously, quite a few of you have been here before. We do cover some of the basic stuff still, and just we review some stuff and add a few videos. And we actually have a quiz in the start of the second half to see how good you're listening. No, it isn't that bad. It's kind of fun. We threw that in there just to mix things up a little bit. I grew up in Wisconsin, so I am a Packer fan. So any Bear fans, there's the door. I went to UW-Madison for my meteorology degree, so I'm a Badger, although we weren't that good this year. But, and then after I got my degree, I actually couldn't go into grad school like I wanted. I had to go to the Navy because I had a ROTC scholarship. So I spent some time dodging mines in the Persian Gulf when Saddam was taking over Kuwait. That was a fun ball of... we missed them all, luckily. But anyway, so after I got out of that, I went into the private meteorology company in Madison, Wisconsin called Weather Central, and got my feet wet because I promptly forgot just about everything I learned in college when I was sitting on a tin can for 3 years. I couldn't believe the things I forgot. It was like a few questions I had to ask the guy next to me, like, what is the 540 line? And they're like, that's the rain snow line, Ed. I'm like, oh, thanks. It's like meteorology 101, the first thing you learn almost. And I was like, so anyway, but yeah, 94, the Weather Service said, come on in, and I love it. The federal government job is actually really a rewarding job. So, all right, we'll move through this, and any questions, just chime right in. It's really informal. But I'll cover just a little bit of why we're here. Spotting is challenging. I mean, there's so many different cloud formations. Even if you think you know what you're seeing, it has other options for you. But it also is inherently dangerous. When you're out there trying to spot for us, you're obviously not in safe shelter at that time. And most of the time when you're out there, more than likely there's a warning in effect. Everybody go to your basement, except you guys. Get outside and go look around and don't get struck by lightning. So it's inherently dangerous because of where you are and what you're doing. But it's important for our severe weather operations. I mean, the information that you're gathering is life-saving information, like you're seeing, tornado development, and we get that into a warning or get a warning out because of what you're reporting. People can take action, because there's a lot of social studies that have been done, and people just don't take action if they don't feel threatened. And a spotter report that it's actually occurring gives that person that, here's the warning, that extra confidence that they should take action instead of just kind of stare out the window and see if they're really going to be threatened by the storm coming into their area. So your timely reports really are critical, and that's why we spend a lot of time and effort coming out to train. We hold about 25 to 30 spotter talks throughout Central Illinois every year. So it's important. We want to give you guys confidence to feel like you can report when things are starting to turn dangerous out there. So that's why we're here. And no spotter guides. In the government budget slices, there's a spotter guide no longer being printed. It's on our website at weather.gov/Lincoln/spotter. That's our training spotter page. Everything is on there that you could ever want to know. Everything that you see here tonight is on that page. There's a handout that you got that kind of guides you to the websites and all the reporting procedures and everything you're going to kind of want to just have at hand when severe weather starts rolling up. But make sure everybody gets one of these sheets just so you have that. And it'll just guide you where to go to refresh your memory after you go home, especially if you fail the quiz. Anyway, all right. If you have mobile phones, silence them or vibrate them so we can keep things rolling. And that's about it. So the first half's going to cover the basics that we've shown quite a few years, but we keep it covering it because it's important. And then the thunderstorm types and features, just so you have an idea of the type of severe weather you may be encountering on any particular day. And then right before the break, we'll cover the major supercells and tornadoes. And then we'll have the quiz. So, all right. Now, why do we have so many thunderstorms in the United States? Well, There's a lot of reasons, but we have about 40 to 50 thunderstorm days, severe thunderstorm days, or annual thunderstorm days, excuse me, not just severe, but throughout the 365 days, about 50 of them have thunderstorms and tornadoes. Illinois is number 5 out of all 50 states, so we are really high on the list. I mean, you know, and a lot of that has to do with spotters reporting more and more tornadoes that we may not have been documenting before. We have more and more people, phones, you know, looking to the sky and snapping pictures and reporting them than in the past. But we certainly are really close to the top of the list when it comes to tornado development. So that's why we're out here. But we have a north-south mountain range in our particular country, which allows very cold Canadian air to come down and interact with the warm Gulf moisture. So those Canadians, nothing good comes out of Canada, right? Cold air, geez. Keep it up there. And moose and snow. But yeah, I lived in Duluth for about 9 years in the Weather Service after I was in Madison. And yeah, you and the moose get really close for a while. But anyway, so the ingredients are all there. South America is a similar north-south mountain range, so they're number 2. But in Europe, they have an east-west mountain range. And that kind of blocks the polar air from reaching the warmer waters of the equator. So. All right, thunderstorm development, the basics. How do these things develop? And the 2 things at the top of the list are required, as well as instability. You need those 3 for sure. Moisture, as I mentioned, the Gulf of Mexico, and also local vegetation. When the crops are in you know, mid-July through August, when they're at peak mature stage, they can draw hundreds of gallons of water out of the ground and through evapotranspiration in the leaves. Pump the dew points about 10 degrees higher than everywhere around them. So depending on how much corn crop and soybean crop are out there, you can really feed thunderstorms, and it does make a difference. And then lift. How are you going to get that warm, moist air to rise? Cold front is the number 1 severe weather producing thing in general, and then a jet stream comes into play as well. But outflow boundaries from thunderstorms themselves, they'll drop a lot of rain and the cold air starts blasting away. If it comes in contact with another outflow boundary, storms blow up along those lines. And sometimes those storms actually will be rotating thunderstorms on a day when you may not expect rotation out of thunderstorms. So we monitor that pretty closely. But those 2 are the first 2 things required for a thunderstorm to develop. And then instability is number 3. And what instability is the tendency of air to want to accelerate in the upward or downward direction once it gets that kick from a cold front or outflow boundary. So basically, the warmer that the air is than its surrounding air, the faster it'll want to rise. And we monitor that pretty closely. Same thing with the descending air. The colder the air is because of hail development and as the precipitation is forming, it starts to rush toward the ground, and the colder it is than the surrounding air in the thunderstorm, the faster it'll descend, reaching the ground, sometimes producing 60, 80 mile an hour wind gusts. So we monitor the temperature changes all the way through the atmosphere pretty closely to determine whether severe weather is going to be possible on any particular day. This is an unstable day in the video right there. You can see kind of a towering cumulus just rapidly blow up through the atmosphere into a full mature thunderstorm as the top of the updraft reaches the top of the weather producing portion of the atmosphere called the troposphere. The stratosphere is right above that anvil usually. It reaches at a point where in the stratosphere it's ozone warmer than just below that. So when I say warmer, I mean it's only minus 40 instead of minus 60. So not balmy, but the temperature change in itself stops that air from rising because it's slightly warmer than. So everything above, like about 10,000 feet is all ice. That top three quarters of that thunderstorm is all ice. All right. On a stable day, the air temperature difference is much, much less. The air start rising, but then it'll quickly become the same temperature as the air around it, and it'll stop rising. And you get fair weather cumulus on a day like that. Really not going to get any thunderstorms out of even precipitation for that matter. Stable day. So that's the other thing we look for. The instability will create a thunderstorm development, but the updraft is particularly important part of the thunderstorm complex. Eventually, rain will start developing and fall out of the thunderstorm, creating a downdraft, but the updraft is where tornadoes start to develop. And that's why we want you guys to try and identify where's the updraft by finding the rain core and then looking for the portion of the storm where air is rising. And you can see in that loop, if I can play it again here, as the air is rising rapidly through the storm tower, you can tell that's the updraft as clouds are all rising in that portion of the storm. And then where the rain is falling, you're going to have more cloud elements dropping. So, and then you look at the base of that. Finding where the updraft is and the downdraft will tell you which way the storm is moving too. Usually, in large thunderstorm complexes, the updraft, you want it on the left and the rain on the right so that you know that the storm is moving from left to right because the wind is pushing the rain downstream. So wherever the rain is in relation to the updraft, that's the direction the storm is moving. So safety in terms of spotting, you want to be south of a storm moving from left to right so you can monitor that updraft area. All right, and the downdraft. Rain-cooled air, sometimes helped with ice and melting ice, will rush to the ground out of a thunderstorm, sometimes creating damaging winds. Oops. So that's basically, look for the blue arrow will tell you where the downdraft is. Wouldn't that be nice? Let's hit the button. Oh, there's the blue line. Yeah, the rain core is pretty obvious most of the time because it's dark sky and you can see where the rain is reaching the ground from a distance especially. So, but that downdraft is just the upstream part of this, where the storm is, or the downstream part of the storm. So it's moving in that direction. All right, wind shear. The thing that actually ramps storms into the severe weather mode is wind shear. Change in wind direction with height on the left side and the change in wind speed with height. And a lot of times there's a combination of both on any particular summer day or all throughout the year, not just in summer. But so wind shear will allow rolling tubes of air to develop, and you can see that on the left side more prominently. But a rolling tube of air is utilized by the updraft, and it's stretched and tilted to create a rotating thunderstorm. And rotating thunderstorms last the longest, create the most severe weather. This is what wind shear might look like in cloud formation as you're kind of monitoring it today before the storms really roll in. The lowest level clouds are kind of moving, into the screen or straight toward the bottom, and then the mid-level clouds are moving from left to right, showing you southerly winds at the ground and westerly winds aloft. If you happen to see that out there on any particular day, you can play your mind in fast motion. It helps. Maybe someday we'll have those little chips in our brain. Huh? That'd be cool. Anyway, so that's what it would look like, wind shear. And it creates a tilted thunderstorm. It creates a tilt between the updraft and the downdraft so that the updraft doesn't get rained out. Sometimes a thunderstorm will be vertical, the rain will develop, fall straight through the updraft and kind of kill the storm. So the most severe storms can live longer because there's a tilt between the updraft and the downdraft, and that wind shear, usually with increasing winds with height, will create a tilted thunderstorm. And there's what we call a flanking line at the development side of the storm. Usually the southwest side of the storm is where the flanking line is. The feed of moist air from the south will start rising, and then that rain-free base is where you'll start to get a wall cloud and possibly funnel or tornado formation. All right. Oh yeah, you can look for the red arrow for the updraft when you're out there, just in case. All right, here's a little bit of a series of images showing you like a rolling tube of air that's out in the nature, and a thunderstorm updraft kind of pulls at the middle part of it. You'll create two rotations in there. The right and the left side will start rotating in opposite directions, but usually in the northern hemisphere, the right rotating one in the clockwise direction will become dominant, and the left mover can break away and split. You'll see that on radar. If you're a radar geek, you'll see storm splits happen. The left moving storm usually is the anticyclone, or the one that's spinning clockwise, and it dies off, and the counterclockwise rotating one becomes dominant and starts becoming a rotating supercell thunderstorm. All right, when you get rotating thunderstorms, you can get very strong updrafts, and that overshooting top can develop if the updraft is strong enough. Basically, you're blasting moisture up all the way into the stratosphere, When you see an overshooting top, large hail is possible, or not possible, but it actually is likely. Especially the longer that overshooting top exists. And as a spotter, if you do see one of those collapse, we have about 15-minute lead time for that large hail to reach the ground. And on average, it's at least an inch, sometimes 2 inches in diameter by the time it still reaches the ground. So it's very large hail that's developed out of an updraft that's strong enough to produce an overshooting top. So even just an overshooting top collapsing is something we really want to know, out of the spotter network if possible, because then we can get ahead of those hail cores reaching the ground. In terms of severe weather features, or at least the strength of the storm anyway, not necessarily severe, but the anvil, the sharper edges to it, that kind of gives you an indication that it's a strong storm. And then the tower being really sharp edges to the storm tower give you an idea that the updraft is very rapidly rising. All right, the rain-free base, the area where the air is rising, so no rain can be falling, and that the stronger the updraft, the quicker the thunderstorm will develop and possibly generate a wall cloud. So as the rain-cooled air reaches the ground, a wall cloud is the ingestion of that rain-cooled air directly into the updraft. So it's battling with a lot of warm air from the south, but that rain-cooled air will form a cloud much quicker than the warm air coming into the whole system from the south. So cold air, lifted just a little bit, it'll start to condense out and create a very abrupt lowering of that rain-free base. And that's a key feature that will tell you, most of the time those are rotating. Almost always the wall clouds are rotating, very few are not, just because of the inherent nature of how they develop. They almost always develop with a supercell thunderstorm, and that's rotating. So, but you'd want to see if cloud elements are actually moving from left to right in a rotating fashion. If you do think you see a wall cloud. So as a spotter, if you're reporting a wall cloud, try and say, I see a rotating wall cloud, or I can't confirm rotation, but I see a wall cloud, things like that. If you can confirm rotation, that's the best. But that's the tornado development portion of the storm, so we really want you to focus on that, and we're going to cover that quite a bit in a lot of the images coming up later. Quick comparison, this is, weak storm on the left, severe storm on the right. It's pretty easy to see. There's almost no anvil at all on the left, where very distinct anvil, and the updraft is very clearly annotated there on the right, and the left comes almost just like towering cumulus there. So just comparison there, you can see, especially if you have an overshooting top, severe storm is likely. All right, any questions on the first part? Okay, good. Thunderstorm types. Now we're going to get into how they evolve based on the severity of wind shear in the atmosphere throughout the day. If there's no wind shear, we get what we call single cell thunderstorms. If there's a little bit more development, organization in the atmosphere in terms of severe weather potential, then you'll get the multi-cell clusters. Eventually, if the severity of the winds aloft are strong enough, it'll turn into a line, what we call a squall line or multi-cell line. And those things move very rapidly, creating widespread damaging winds. And then eventually, if you can get those rotating thunderstorm cells to develop, you'll get what we call a supercell. And we'll cover all of those types right now. When the updraft and downdraft are almost vertical into each other, the rain core will basically rain out the updraft and cut it off and stop the storm in about 30 to 60 minutes from initiation of updraft till the rain core basically kills the updraft, and the storm will just rain itself out in about an hour. So not a lot of severe weather there, as you might imagine. A few gusty winds, maybe some small hail. Flooding might be an issue, but it's just not raining long enough usually to create much of an issue there. So just be, when you see a vertical thunderstorm, it's probably not going to produce severe weather. A complex of storms altogether, which we see a lot of, multiple phases of updrafts and downdrafts. The left half of it is usually almost all updraft, and then you get the middle, then you finally have that rain core develop. And then in varying stages of the life cycle as you move off to the right. And this whole complex will kind of sit in one spot. You'll have the flanking line develop, an updraft and a downdraft, the mature thunderstorm in the middle, and then dissipating. And the complex itself may not even move all that far left or right or upstream. So you'll get flash flooding as a prominent portion of, or possibility out of these storms. Downburst winds as well. Tornadoes not is likely, but heavy rains for sure out of a multi-cell cluster that doesn't really move. And then some damaging wind and hail possible. Tornado threat is low. Downbursts, which are possible in multi-cell clusters, it's that rain-cooled air rapidly descending, and that instability is supplying that additional acceleration. 100-mile-an-hour winds are not uncommon out of some of these downbursts that occur in thunderstorms around the area. Most of the downbursts in Illinois are with very heavy rain. When you get over into like the plains or around Denver, you'll have dry microbursts where all of a sudden a big ball of rain will start descending and evaporate completely, just creating basically a ball of very, very cold air that rushes to the ground. So you'll see nothing happening, and all of a sudden the winds will be 70, 80 miles an hour out of you couldn't see it coming, really. Yeah, the airport loves that out in Denver. I've landed in a few of those situations, and the pilots, yeah. Luckily, they turn off the microphone because I'm sure a few four-letter words come flying out when they're landing into something like that. But we've always landed safely. But it's crazy out there when these dry microbursts occur. But they can last several minutes. Like this is EF1, almost EF2 level of wind speed potential for damage, and it can last several minutes. Whereas a tornado blasting through, it's 30 seconds, maybe a minute at most, depending on the width of the tornado. But this can be several minutes of EF1, possibly EF2 level severe winds. So severe thunderstorms are not something you should take lightly, although most of the time people hear severe thunderstorm warning like, so what? It's not a tornado warning yet. I'll wait till it's a tornado warning before I really get concerned. Well, severe thunderstorm warnings can pack a punch depending on what's going on that day. All right. And visually identifying a downburst, when the rain core is hitting the ground, you'll get a rain foot. If you ever see a rain foot, the rain doesn't usually fall sideways. So there's a reason. The winds are really, really moving. 60, 80, sometimes 100 mile an hour create that rain foot. The rain's kind of moving sideways. It's no joke. It's a lot of wind speed. And if you ever see a rain foot from a distance, it's probably causing at least tree damage, if not power lines. Maybe a few cows, depending on where it's going through. I don't know. But yeah, I grew up in Wisconsin around cows, so we'll make that a reference. And if anybody watched Twister, cows fly, so. It's true. Yeah, there's a lot of stuff in that movie that's not meteorologically correct, but we love it. We love that movie, man. It's great. All right, multi-cell cluster in a time lapse here. You can see the flanking line on the left. Mature thunderstorm in the middle with the updraft and downdraft in tandem, and then dissipating as it kind of heads off to the right of that image. And if you looked at where that the most severe portion of the storm or the updraft and downdraft are in relation to a feature on the ground, that whole complex doesn't really move left or right for the majority of this entire loop. That's why multi-cell clusters can produce 3 inches of rain in a couple hours if they don't really move, and that's going to cause a lot of flooding problems if that ever happens. They're not always that stationary, but chances are it can happen, so be aware of that. And this is a image loop. The greens and blues are lighter rain, and then the heavier rain is going to show up in the reds. And that just shows you the updrafts. It's kind of a quick loop, but the flanking line will be towards where C is there, and just show how quickly it turns into a rain-producing updraft, downdraft couplet there. Landspout potential is kind of where the updraft is developing there, and we'll cover landspouts in a little bit. All right, the next slide, how about that? Landspouts, basically where updraft is becoming rapidly organized. Before rain forms, you'll get landspouts. These things are terrible to try and get ahead of as a radar operator because there's no rain. We look for rain when we're trying to figure out where we want to put a tornado warning out. And these are tornadoes. They have an updraft that's associated with a cloud above it. So we do issue tornado warnings on these, but the only time we really know they're happening is because you guys report them. The rotation on the radar just isn't there because the rotation is basically from the base of the cloud to the ground, and there's no rain. We can see air motions with the radar, but you got to be really paying attention, and it's got to be pretty close to the radar for us to really catch a landspout rotation. So, as spotters start reporting these things, we'll get a tornado warning out. We'll kind of box the whole convergent line that we see in the observations. It's a lot harder because we're used to tracking a storm from A to B, and it's moving this speed, and that's how, get out of the way because it's moving here. But for this, we issue a warning, and it's basically, don't drive into the tornado. And we do have to tell people this. Because we have some videos that didn't follow that order. Anyway, so they're not usually that strong. Wind speeds at the ground with these landspouts, possibly in the 70 to 80 mile an hour range with low EF0. Most of the time they don't hit things because they don't move. If you're unlucky enough to have one that form right on your house, it's possible to get some structural damage there to roofs and maybe some siding. But for the most part, these are not damage producing situations. But we, just in case somebody's moving around and it can jostle a car a little bit if it hits. So we do issue tornado warnings for these. But they're very frustrating because you can't get ahead of them most of the time. And they're almost nearly transparent. This is one near El Paso, one of the widest ones I've ever seen, and was caught on video. Kind of like a landspouts or water spouts that we took our ship around. We kind of did a loop-de-loo, and Captain let me drive the ship in circles through 3 different water spouts that kind of popped up, and it was kind of fun. Although the operations guy didn't really like me too much. He's like, wait a minute, knock it off. Anyway, yeah, basically nothing on radar, but a lot of upward motion and basically stretching rolling tubes of air that are available on a particular day. It's a stationary front where cold and warm air are just kind of sitting there. Air is flowing together and converging and rising, and all of a sudden, one of those tubes of rotation gets stretched just right, and it basically forms into a tornado. Late April through June is our target zone for landspouts, and actually the only recorded ones that we've ever had really in central Illinois is the last 8 to 10 days of May. So we got a little bit of time before the typical season. This one was May 28th. Somebody was recording that El Paso area landspout. And they usually are very faintly visible unless this one's going through a field that had already been harvested, so it's getting some dirt and dust, making it a little bit more prominent. So that's what you might see out there if there's a landspout day. And then it usually lasts about 30, 45 minutes of 3, 4, 5. Sometimes one day we had about 8 landspouts develop on a convergent line, and then they're done. So you issue a warning, and then they just don't develop again. All right. Now, moving on to squall lines. The very rapidly moving forward motion out of this thunderstorm complex changes things around. As a spotter, you're not looking for the updraft on the left and the rain core on the right. That's where the storm's moving. Well, this storm moves so fast in the forward direction, the updraft is forced into the forward flank of the storm. So, as these things are approaching you, tornado development is going to be on the leading edge. If there are any rolling tubes of air that get drawn into the leading edge of this thing, you can create tornadoes out of very short-lived, no notice, because there's not really rotation that you're going to see on the radar most of the time as these things start forming. So it's kind of a dangerous situation, because either you're going to get a tornado form right over the top of you, or the downburst will be 70 miles an hour and you'll get blown away. So you want to have safe shelter really planned out closely in terms of timing when a squall line is approaching. Mainly because they're so long, north to south. These things are like horizon to horizon as they're coming at you. Basically, it looks like Independence Day coming at you, really. It's just huge, dark sky in the distance, especially the deeper the leading edge of that shelf cloud, or the leading edge of a squall line is called a shelf cloud. It just looks like an airplane wing, and very raggedy, dark base where the downburst winds are starting to churn and create what we call scud clouds, or detached clouds that are separating from the thunderstorm. A lot of those could look like funnel clouds, and we've gotten a lot of funnel cloud reports on the leading edge of a system like this, because you can see little appendages start coming out, and then all of a sudden they'll swirl and get detached and kicked out by the 60 to 80 mile an hour winds that are blasting away from this thunderstorm. So the deeper the leading edge, the higher potential that it's organized enough for damaging downburst winds behind it. And the darker the horizon underneath where the rain core is, gives you an indication of the depth of the storm. So the darker it is and the deeper the leading edge, be ready. And here's another one that's pretty deep, almost an airplane kind of wing looking structure. Dark horizon. This one produced 60 to 70 mile an hour winds near Hayworth back in June 7th of 2015. So another example of a severe squall line, deep leading edge, very, very dark horizon. Once again, 60 to 70 mile an hour winds out of that one near Winchester. Here's one 70 to 80 mile an hour. That almost looks like a supercell, really, but it's just a very bowed segment of that squall line, and that's why it looks like that. It actually is a shelf cloud with very turbulent base and rain core behind it. And this one produced 70 to 80 mile an hour winds again, kind of a common theme there. 80 mile an hour winds can roll over mobile homes, so it's a significant amount of wind. And it also caused structural damage to homes in terms of siding and roofing. And if it's throwing around some tree branches and stuff, it can break your windows too. So these are definitely severe weather damage producing storms. All right, and some squall lines. Oh, that was where our electronic technician was near his home, and he was taking pictures of that as it rolled through and blasted right through his area there in Hudson, where he was. All right, and here's a few images of non-severe squall lines, at least the shelf cloud portion of the storm. Not a lot of structure there. It's not nearly as dark as you can see. 30 to 40 mile an hour winds were reported out of this one, July 7th of 2016. Here's another one. The horizon is kind of not nearly as dark, and the leading edge of that squall line and shelf cloud is not nearly airplane wing-esque, so to speak. Another one looks a little more organized, kind of a dark in the distance with 50 mile an hour winds reported near El Paso. 58 miles an hour and higher is our severe thunderstorm warning trigger. Usually when branches about 3 inches in diameter start falling. So that's what we trigger our warnings on, is almost 60 mile an hour winds. But 50 is pretty close, and depending on how old the trees are, sometimes you'll get some tree damage reports out of 50 mile an hour winds. And this is what squall lines can look like on radar. Tremendous distance from north to south in terms of how long they are. So it's something you can't get out of the way of. It's as a spotter, you can't shift south of the supercell and it's moving away and pass by you in safe order. These things you can't get out of the way. And not only is the severe wind threat in the apex of the bowing segments where the winds are really pushing that thunderstorm complex out, creating the bulge forward. That's where the most damage is occurring, at the farthest point forward of the bow, the apex of the bow. 80 or plus mile an hour winds. But in the inflection points, or where the direction changes, where they come together as the bows each kind of come together in a scalloped form there, that inflection point is where a rotation develops. And we'll see it on radar. All of a sudden you'll see the line kind of surge in multiple spots, and the inflection point turns into a tornado development zone. And that can happen right on top of you. So a squall line's coming in, looks fine, no big deal, but all of a sudden, all the bowing segments start forming, and then you're on top, you're directly underneath one of those inflection points or tornado zones. And we did have 2 tornadoes reported just east of the Quad Cities in Moline out of this event. Did tornadoes happen at the other inflection points? Based on the atmosphere, probably, but we didn't have anybody report it. They develop quickly and they dissipate quickly, but they can pack a punch too. So I don't know the EF strength of those tornadoes offhand, but they can be EF2 or even close to EF3, depending on how fast the squall line is moving and how quick the rotation is. But you just be aware of that as a spotter. It's very dangerous. The leading edge is where the tornadoes form, and it could happen right on top of you. Go ahead.
Rain-wrapped tornadoes as well.
Correct. Yeah, this is also where rain can start to, basically. It's not, we have what we call later on in this spotter class, high precipitation supercells, a little different animal, but rain wraps around the updraft completely. You can't see the rain-free base. In this particular case, the rotations are developing where rain is falling, and the rain that's falling to the south of that updraft will kind of shroud where you would possibly be able to see the tornado formation. So these tornadoes can actually hit you within a rain core almost, and you can't even see them coming. So that's a good point. Thanks for pointing that out. All right, and this squall line came through Illinois once again. You know, it kind of intensified right over the top of central Illinois here. And our crack ET, Mark Stacy, was at his house in Hayworth, kind of looking to the west, seeing this thing develop, and an inflection point developed right near him. 70 to 90 mile an hour winds were already being reported out of this system by the time it got to him, with roofs damaged, large sheds blown apart, as well as mobile homes damaged out of this particular complex. But this is what he saw, that inflection point developing. The southern portion of that was blowing up very quickly, and the more mature part of the line was up to the north. But right where those two shelf clouds, based on where the winds were blowing aloft, creating those bowing segments, there was a rotation that developed. And that's where he is based on the radar image right now, looking to the southwest there, right on top of him. And there's the wall cloud that started to develop. And on our radar, what we look for on the reds and greens on the velocity images is green is toward the radar, which was off to the southwest, and then red is away. And the closer those brighter reds and greens are together, the better chance of tornado development. And this was kind of faint. It wasn't jumping out at you, but when you zoom in and kind of look at things, when that inflection point developed, he saw a very pronounced rotation in the wall cloud. Hail was about an inch and a half 10 minutes later, and 70 mile an hour winds as it moved through his area. But you just got to be very careful with squall lines, because these things spin up quickly. And if you're not really paying attention on the radar, I mean, that's kind of a subtle feature. And this can happen all the way up and down the squall line. What are we going to warn on? I mean, if we issued a tornado warning on every time we saw a little circulation develop on one of the squall lines, you guys would get plastered with tornado warnings, I'm telling you. It's so hard to figure out which ones are going to be tornado producers, because they don't last long. The circulation doesn't usually crank up and turn into a major, gate to gate, red and green immediately next to each other. It's just subtle, and if we have a spotter out there like this, our ET, we got a report of that wall cloud forming, and we did issue, I think we did issue a tornado warning on that because of what he saw there. You see something like that and a rotation on radar, you're not going to just throw it aside. So spotter reports in these squall line situations are very important, but obviously you're in a very dangerous situation. He's right there. That tornado could have developed, literally on top of him. All right, so that's the first three levels of severity in terms of development. And then the worst of the worst, we call them the supercells, and the tornadoes that they produce are some of the strongest that you'll ever see. The day that we had the EF4 go through Washington and in a good part of Tazewell County, that was, EF4 level out of a supercell thunderstorm. Same thing with the Parson plant back in 2004, I believe. So, the strongest tornadoes that you'll ever see are going to be coming from these storms. And that's why we cover them, because life-threatening situations are out of those EF3 to EF4, EF5 level winds, 200 mile an hour or greater or so. So, we max out everything on these storms, supercells, the rotating thunderstorms, because of that. The most significant damage, as I mentioned, golf ball or larger hail is an automatic clue that you have a supercell thunderstorm, because golf ball hail, which is about 2 to 2.5 inches, doesn't develop out of just general thunderstorms. It has to be a storm that lives longer, like 2 to 3 hours at least, for that kind of hail to develop. All right, here's a classic supercell on the left in terms of an image from a distance, and on the right, a high precipitation supercell. Very dangerous to spot, obviously. The rain core has been wrapped around the updraft, and you can't see the rain-free base anymore. You possibly could see like funnel formation, but most of the time, before a tornado even develops, the rain core will wrap around. The best part of the storm where you can get severe weather information. So we will cover both of these. Now the classic supercell, you have that view of the rain-free base and the wall cloud. They're highly organized because of the wind shear that's in the atmosphere at the time. And the entire column rotates, and we call it a mesocyclone. Kind of looks like the Michelin Man. He's looking a little pudgy there, or the Kool-Aid guy on the right. Oh yeah. Everybody knows the Kool-Aid guy, right? Or am I dating myself? Man, am I that old? The Kool-Aid guy. Everyone's seen him. Anyway, so either the Kool-Aid guy or the Michelin Man, you're dealing with a supercell thunderstorm. Didn't think you'd hear about that tonight, did you? This is a spotter class. Why are we talking about tires? All right, wall clouds. That's where the most important rotation is going to be developing is in the wall cloud region, where the funnel clouds usually develop out of, and there's a leading edge of these wall clouds that we call, oddly enough, the tail cloud. The leading edge of a wall cloud is called the tail cloud. Once again, look for the red line out there. That's the updraft. We're keeping a theme here on the red. Persistent lowering of the rain-free base is kind of key too. Sometimes you'll have a little bit of a lowering of the base of the storm, and then it'll kind of dissipate. But if you're going to get enough organization for tornado production, it's going to be a persistent lowering and a rotating wall cloud as well. And the tail cloud will point down and toward its source of rain-cooled air, or the direction of motion of that storm. So wherever the rain core is on these supercell thunderstorms, you'll be able to tell the direction of motion, because that tail cloud will be feeding directly off of that source of rainy cooled air. And here's a video, and you can see every cloud element anywhere near the leading edge of that just lifting up and into the updraft. And this whole segment here is the wall cloud. Multiple kind of appendages coming out of that. So it's hard to, as a spotter, where do you focus? The back? Funnels form out of the back a lot. It looks like something might be happening there on the left side. You're immediately drawn to what's closest to the ground, but not necessarily the most severe part of the wall cloud. So, keeping your eyes kind of peeled to the entire base of that. But if you're looking at a wall cloud, the wind will be at your back, because these look very similar to shelf clouds. And if you're not looking at your radar on your phone or whatever, you can definitely feel a wind, 30, 40 mile an hour winds at your back, because these wall clouds are part of a big Hoover vacuum. If you have 100, 150 mile an hour updraft, that wind's got to come from somewhere. And all around the base of these thunderstorms, you'll have very prominent wind at your back. Shelf clouds, as part of squall lines, you'll have generally a light breeze, or nothing at your back at least. For the most part, it'll be much lighter winds, and you'll see every cloud element near the base of a shelf cloud actually detaching and moving away. So down and away is a shelf cloud, up and in is a cloud, and that wind at your back. All right, more supercell images and wall clouds, especially here, the very abrupt lowering of that rain-free base on the leading edge. This whole darkening here is actually the wall cloud. And then this is an additional abrupt lowering there. It looks like a couple of them. That one isn't actually in a distance, but the most important part of this particular wall cloud is on the leading edge there, it looks like. All right, another wall cloud. That's pretty abrupt lowering there, and then a very prominent tail cloud from April 27th, 2016 near Raymond. And a funnel, typically if it's going to form, it's going to be right in the wall cloud portion of the storm. And a brief tornado actually occurred out of this. If the funnel cloud is about halfway or more to the ground, more than likely it's going to get the rest of the way, or at least if it's more than halfway to the ground, there probably is some kind of resultant circulation at the ground already. This is just the condensation funnel, where there's enough moisture to actually produce a cloud. But that doesn't mean there's not rotation through the rest of the column. It's just too dry to form a cloud, and it hasn't hit a dusty field to form, the rest of the to identify the column of air that's rising there. So, more than halfway to the ground, probably a tornado. But don't report a tornado until you actually see debris or dust or some visual clue that circulation is on the ground. But just keep that in mind. And a lot of times you'll have a tree line kind of blocking the ground. So. You don't always get a nice clear view to the ground, but as a spotter, keep that in mind. There's another wall cloud. This one did not produce a tornado. And you can see above it, it's not as organized, but it's certainly enough updraft to produce a thunderstorm. But this one, that's a pretty abrupt lowering of the rain-free base. And you can see the rain core over here is on the left. So he's looking to the south at this complex that's moving from right to left. Still a safe spot in general in terms of motion of the storm, but it almost looks like a tail cloud here, but it's actually on the other side of the storm. You just got a bad angle at this one here. But it doesn't matter what it looks like really in terms of tornado production. darkness and stuff like that. It's all a matter of the organization in the atmosphere. And is there a rolling tube of air that this storm can feed off of to actually create the connection to the ground? So only about 5 to 10% of all rotating thunderstorms produce tornadoes across the entire globe. And there's about 10,000 thunderstorms a day across the the entire Earth. So very, very few rotating thunderstorms actually end up producing tornadoes. So that's why, if we issued tornado warnings every time we had a big supercell roll through, we'd plaster you with tornado warnings that didn't really, cause any harm. So it's important as a spotter to just, give us all the information you can so that when it does show you that it could possibly produce a tornado, we can get ahead of it. All right, here's an image of the day that an EF4 went through central Illinois and hit Rochelle, just north of our forecast area. But one thing that we can sometimes see on radar is called a debris ball. On the end of the hook echo, if we have a very prominent, red, sometimes even white or pinks, where we normally think it's hail, it's actually buildings, trees, things get lofted by the tornado and create that debris ball. And we see that on radar, giving us confirmation basically that something has reached the ground and caused non-meteorological items to get launched in the air. And actually the dual polarization upgrade that we have to our radar, there's a product called correlation coefficient, CC. And I don't know if anybody uses radar scope out there, spotters. I use it. I'm not promoting it, but for me it's the easiest way to jump around between our dual polarization products. And if you look for that CC or correlation coefficient product, it'll go from 100, which is very, very uniform rain, to like 20 or 30, which a very prominent color change on the image. And if it's right near where there's a rotation, guess what? A tornado on the ground. So even if we don't get some spotter reports out of a particular rotation and we see that debris ball or a correlation coefficient very low number on the CC image, we can basically put confirmation into our warnings out of that. At night it's super helpful for us because we're tracking a storm and not a lot of spotters are running around in the middle of the night. And we can actually try and get some word out that this is a confirmed tornado based on radar images that we've got out of our dual polarization upgrade. That's a textbook case. Here's a little weaker kind of a rotation on radar, at least in terms of the hook echo, but it certainly was packing a punch because this is the Washburn tornado day that ended up producing EF3 damage in the Washburn area. And there's Washburn and there's the circulation. So in terms of reflectivity, this was definitely not a high precipitation supercell, but it developed a very wide tornado that day. It was more than a quarter mile wide, almost a half mile at some points as it passed, and this is when it's beyond Washburn. So it never really developed a tremendous hook echo because there's not enough rain with this system, but the winds were just right to produce a very strong tornado circulation. All right, in terms of life cycle of a thunderstorm or a tornado, obviously you're going to start with that funnel cloud. Hopefully, we can get some reports out of that. But one thing we want to cover just before the tornado formation is a clear slot around the wall cloud. Rear flank downdraft air, or RFD air, we found out of a lot of research that have come out of tornado studies, is the dry air from the backside of the storm getting forced to the ground by kind of a jet stream flow or low-level jet pushing in the backside of the storm, forcing it to the ground. Sometimes that air is a little warmer than the surrounding air or buoyant, and it'll want to rise. So as soon as it reaches the ground, it's warm enough that it's naturally buoyant, and it creates just the right combination of spin to spin up a tornado. And the clear slot is the result of that dry air reaching the lower levels of the storm. And you'll see a very prominent clearing, and it's in a lot of tornado images and funnel cloud images, where the wall cloud itself has a lightening or a clearing on the south-southwest flank of that wall cloud. And once we see that, tornado spin up and development can be minutes away. I know as you're trying to get this information into the office, tornado could already be developing. But if you ever do see a clear slot around a wall cloud, that is huge information for us, because then we can immediately shoot out a warning and get ahead of these things. Because when the clear slot does develop, that's one key thing that has been seen ahead of a lot of tornado development. It's not always buoyant air that's in that rear flowing downdraft. Sometimes it's a little cold and it won't want to rise, or if it does start to rise, it'll level off and it won't generate enough spin that reaches the base of that wall cloud. So it's not 100%, but you know, we'll take our chances when we see something like that, or when you guys see something like that. All right. You know, as the rotation starts to spin up stronger and stronger, you'll get that funnel, a very smooth edge. You can see some of the other clouds here, nothing really prominent in terms of smooth nature, but that middle obvious funnel formation there. Probably not any kind of resultant circulation on the ground, but once you do see a dust whirl at the ground, that's when you can basically say that a tornado has developed. And there you can see the funnel's more than halfway to the ground, and finally you see a dust swirl in that column of rotation. Tornado development, 2 minutes after that funnel formation. So pretty quickly, less than 2 minutes. And then the mature stage of a thunderstorm, or a tornado, excuse me, you know, that's where you get the most damage. It's at its peak wind speeds, and depending on what it hits, if it goes through a cornfield and doesn't hit anything, we can't call it an EF4 tornado. It could have 200, 250 mile an hour winds. That corn is getting obliterated. You know, we've even had blacktop get scoured off the ground. But we need structural damage to actually be able to say what this wind speed was. I don't recall that there's a case for, you know, road ripping up to give it an EF level, but I have to check the numbers on that. But anyway, you know, the mature stage is definitely when the most damage is occurring, and a lot of debris and dust or whatever gets picked up by the tornado can actually shroud the actual tornado. But you can pretty much discern that if there's that much debris and dust getting whirled around, it's probably still in contact with the ground. Eventually that rear flowing downdraft will cut off and separate the updraft from that flow of circulation and warm air, and that creates what we call the rope stage. So that rear flowing downdraft will continue to wrap around and almost create a circle around the wall cloud at the ground level, and basically cut it off from its source of how it became a tornado in the first place. So the rear flowing downdraft generates the tornado and also kills the tornado in the end. So you just got to be mindful. In the rope stage, there's a lot of meandering of the tornado on the ground, and you don't want to get very close at all to a roping stage tornado, because you can, you know, get in harm's way pretty quick. There's still damage that can be occurring out of a rope tornado. It doesn't mean it's really weak winds. It actually can still be producing very similar winds to what it had earlier on, so just be aware of that. And then eventually dissipates completely. It's not always the end of the situation, because we have what we call cyclic supercells, or cyclic tornado genesis, that can occur. As that rear flowing downdraft cuts off the supply of rotation and moisture for the first tornado, the next rotation can be developing because of that same rear flowing downdraft a little bit upstream. You'll start to get what we call you know, a funnel formation on the new rotation that's developing. So this, you know, particular funnel is going to eventually die off. And then the next one in this particular image, at the same time, it's almost already a tornado on the ground before the first one is dissipated completely. And as a spotter, if you're on the southeast part of the storm motion, that could be right on top of you. And it's a dangerous situation. I mean, you're obviously going to be concentrating on the tornado, but if you don't kind of look at your surroundings and the cloud formations above you as well, you could be in harm's way pretty quickly.
Now you got time, I'm shooting good video, good steady video.
I heard that roar.
Yes, yes.
Oh God, is that another one over to the
Where? MID, got the whole sky rotating above me. We gotta get east, it's moving south. I'm off the door!
Honey? Can I get in too? Oh, shucks. Sorry about that. Is our insurance up to date, honey? What? That's why you have two spotters all the time. Yeah, you never want to spot alone, so you can have one available to lock the doors. What? Imagine that ride down the road. What are you doing? This is our safe zone. So anyway, don't do that. Anyway, so you got to be aware of what's above you. Obviously, that's one case, and you know, there are others that that I'm sure are out there. And if you ever have a situation like that you're videotaping, please send it to us so we can include you in our spotter talk next year. Always looking for new stuff. But all right, HP Supercells. Not a lot to to basically report there. After the rain core wraps around, you got your Michelin man going on there, and then a lot of rain below it. So severe weather reporting wise, it's not much you can do other than to say what you saw before the rain wrapped around the core of the updraft. But here's an HP Supercell, somebody driving right at it. What? Tail cloud there, so it is moving from left to right, and he's driving in the path of that thing. Another HP Supercell. I mean, the safest zone is to the south, just to let it pass by it without it actually hitting you. But if you are able to watch rotation for a while, and it actually is a high precipitation supercell situation, you're on the wrong side of that storm. You're in the path of that HP supercell. So it's a pretty dangerous situation if you can actually see the rotation for any amount of time. And if you're actually looking at a storm and the funnel cloud isn't moving left to right, it's going to reach you eventually. Same thing in the Navy. We're like what we call the constant bearing decreasing range, CBDR. If you have a ship and you're looking out the window and you put a little tick mark on the window, and 10 minutes later that tick mark is still in the window in the same spot, the captain kind of gets a little nervous. I found that out the hard way once. And we had a 10,000 yard buffer that if we ever got a ship in that 10,000 yard zone or 5 miles, you have to call a captain even if it's 2 in the morning. And I didn't do that one day, and he wasn't impressed. But Captain, it's 2 miles away. But anyway, yeah, and if stuff starts coming at you and it's not moving left to right, it's going to come to you eventually. So very dangerous situation if you don't have right to left motion, lateral motion. All right, here's an HP supercell on radar. You got the heavy rain and hail, and then the lighter rain's getting wrapped all the way around. And here's your rear flank downdraft on radar. That's not rain, that's actually just cloud density change, or it's air density mass change. Very rain cooled air blasting, dry air blasting down the south side. And if you're a spotter, you won't even see it coming. All of a sudden the winds will pick up to about 80 miles an hour and knock you over without, you think you're in a safe spot, but that rear flank downdraft is always a gotcha. Got to be ready for it, especially in severe weather events like this. And if you're looking at radar scope and you got the velocity image, you can see it coming. That notch in the northern portion of this image here, or the central portion of the image I should say, is where the rotation is. And that rain is getting wrapped and blocking you from being able to see that rain-free base. We had the Washington tornado day where one was developing and moving near Gifford. And it was an HP supercell, and you would think, oh, there's the rotation right there. But if you look at the velocity images, it was actually within the rain core. And that tornado was completely rain wrapped. It actually was inside where the rain was falling, which is highly unusual, but it can happen. So don't always just look at your reflectivity image and go, I know where that is, and I'm in a safe spot. Well, not necessarily. So be very aware if you are looking at radar as a spotter. Always got to have that velocity image up to see where the actual, the most dangerous part of that storm is. Okay, outline of the second half. There we're going to get to spotter challenges. Some of the stuff that was in the quiz that we didn't cover yet. So a lot of lookalikes, or a few of them anyway, just to give you guys a chance to see some of that. And then the spotter guidelines that are important for you guys preparing for spotting, and then how to stay safe. And then at the end we'll show you how to report and what to report, which is all on the sheet that you have, the spotter sheet that you grabbed when you came on in. So a lot of this stuff here that we're going to cover in the last half of this second half is on your sheet to help you refer to later on when you need you out there spotting for us. But challenges, take time so you aren't fooled. When I moved down here from Duluth, I had been in the Weather Service already about 14 years, and I thought I knew my stuff. Severe weather wasn't that often up there, but I'd been doing spotter talks, and I'm the expert, right? I was at my house in Lincoln, and I was just looking off into the distance toward the storm line coming at us, and all of a sudden I see a really prominent wedge, not tornado, but a funnel, dark funnel shape, and it was smooth edges. And I'm like, holy cow, man, I got a tornado. I hadn't actually seen a tornado form up to that point. So I'm getting on my phone. I didn't know the number, so I'm trying to dial it, and I'm a little clumsy, and I'm going, boop, 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 and I'm looking up and then dumping, dialing, and then it starts to ring, and I look up again, and all of a sudden, it just kind of fades into nothing. And I'm like, what It was actually a shadow between two clouds that were just positioned. So I'm like, hang up, hang up, hang up, hang up. I got a shadow moving northeast at 30 miles an hour. That baby is gonna do some damage, man. You know, so I, humble pie in another way, man. You know, I'm like, holy cow, man, I almost reported a shadow. That was pretty, yeah. So, take your time. Don't get on the phone until you really know what you want to report and you can confirm what it is. I'd never seen anything like that. It was, got me. So is this a tornado or a funnel? Yeah, from this distance and nothing prominent, it's more than halfway to the ground. Is it on the ground? Probably. But can you report it? Not until you have visual confirmation. No debris is lofted yet, or you know, watch it carefully. It's definitely close enough to the ground to actually be a connection. Just can't see it yet. So only report what you can confirm with visual sighting. And of course, in this particular case, as you saw earlier on in the video, the start of the Washington tornado, just as it crossed the river, and it did cross the river. Rivers do not save you. This started in the Peoria County side and crossed the river, came into Pekin, and you know, started ramping up. Obviously, at this point, it's not causing tremendous amounts of damage, but it's ramping up as it goes through Pekin and East Peoria before it gets to Washington. But that storm is moving about 55 to 60 miles an hour with the tornado circulation on the ground, which is kind of unusual. Getting lead time on a storm moving 60 miles an hour kind of cuts our potential for helping people in half, really, because storms usually move 30, 35 miles an hour. When you got something moving 60, trying to get the word out lead time-wise is really difficult. But spotter reports helped tremendously that day because we got a lot of feedback that this thing was, you know, starting to ramp up quickly. So anyway, that was a tornado, as you found out in the quiz. All right, lookalikes. Scud clouds. Scud clouds basically are detached clouds from the base of the storm, kind of churning a lot in the same motions as funnels at times. But they will have motion that is different than the thunderstorm above them. If there's ever motion that is faster or slower than the storm above it, it means it's detached and it's not a funnel or a wall cloud, depending on what you're looking at. So these are easily confused at night or even at dusk. Things aren't lit up really well. But you want to look for rotation as best you can that's really prominent. The rotation of a funnel is going to be pretty rapid, enough to create the smooth edges where it connects to the base of the storm. So scud clouds are all over out there, and even shadows. So even the shadow knows. So all sorts of things can happen to create very confused looking, cloud elements out there. And this one looks a lot like a funnel in terms of, the overall structure from a distance, but quickly you would notice that its attachment point to the updraft of the storm is, and this actually probably could be a shelf cloud really in reality if we had a bigger picture of this. Because scud clouds often form on the leading edge of a squall line, and they'll be moving and detached and moving away from where the rain core is. The air is rushing to the ground behind the leading edge of the shelf cloud, and actually these cloud elements more than likely would be moving out and away from the base of the storm. So that's another key thing to keep in mind. And if there's no wind at your back, probably not looking at a wall cloud / funnel cloud, but the situation. All things to keep in mind, which you can't get from a picture. We should have a big fan at the back of the room that I can flip on when it's a wall cloud. It'd be cool. It's like Disney, they blow stuff at your legs and water splashes on you. And we don't quite have that kind of technology yet, but wait till next year. Throw a couple $1 million at our spotter talks and see what we can do. Fraud, waste, and abuse line. Here's the number. But we have the awesome spotter talk. People come from Kansas to do ours. Anyway, scud clouds again here. Detached cloud elements moving. There's relative motion from the base of the cloud to the scud cloud as it's moving across. This one's obviously a static image, but you don't have a real smooth connection point once again. That's kind of a key element to funnel cloud formation. Where it's connected to the base of that storm, it's going to be smooth and very obviously rotating. A couple of lowerings, cloud elements there, and it almost looks real good. Updraft area, rain core off to the right. But if you looked at the whole image, probably it's the leading edge of a shelf cloud with the rain core behind, and this is the leading edge of the the leading airplane wing kind of looking. Obviously, this image doesn't have every detail there, but these are scud clouds. All right, rain shafts and virga. Virga is rain that falls from the base of the cloud but evaporates before it reaches the ground, just like the dry microbursts out in Colorado. Same type of situation, but they look very much like funnels, depending on your angle of view and how it's lit up and what time of the day or night it is, or evening, I should say. But just look at that it's kind of a wispy nature, not really rotating if you looked at it for any points of time. Rain shafts don't rotate, and neither does virga. So it wouldn't take too much, and you can see above this particular rain that's falling, it's not really a thunderstorm at all. So you got to keep that in mind. It may be the updraft portion of evolution possibly, but with rain falling and nothing really above it that would warrant kind of funnel wall cloud formations. Just keep all those ideas in mind as you're trying to figure out what you're looking at. And there's a rain shaft all the way to the ground. Certainly looks like it from a distance, especially if that was just getting lit up by lightning. You're at home and just kind of glancing out and there's frequent lightning lighting that up. It would definitely look like a funnel or a tornado on the ground. So it's real tough at night to find rotation when all you're able to utilize is lightning. But looking at radar would help. If you have a radar scope, you're a radar geek, you would be able to see that this thing wouldn't look anything like a tornado-producing storm, or even may not even be on radar because it's so shallow. But having a radar image and a velocity image on your phone is huge in terms of spotting, just to take a lot of the question marks out of your mind of what you're really looking at. So here's another rain shaft image. Once again, not a real smooth side to this at any point, really. Real wispy, definitely giving you an idea that it's not a rotating funnel or tornado. And gustnadoes, the one that everyone almost got wrong. Yeah, these outflow boundaries of the thunderstorm complexes, the connection point to the flanking line of that outflow boundary is usually where you're getting your gustnadoes, where the strongest winds are out of that outflow boundary. And that thin blue line is just a density gradient between very cold air and the warm ambient air across the area. And that shows up on radar and in our velocity images as well. But creates a situation where the spin is generated at the ground without a correlation from the base of the updraft. Usually isn't even an updraft right there. This is all downdraft based wind that curls up just enough and stretches a little bit of rotation that's in a tube of air near the ground and creates that enhanced rotation or a little bit of a gustnado. It doesn't have a connection source of rotation with the cloud above it at all. So that is not a tornado. We do not issue tornado warnings on gustnadoes. Can they cause a little bit of extra damage? Possibly in the rotating column there, but they're usually so brief that the outflow winds from the storm itself are causing as much or more damage than any kind of circulation in the gustnado portion there. They're usually so short-lived or very hard to see that unless you're videoing it and you can go back and look at it, you may not even know that you're looking at a gustnado in the debris or the dust cloud that's kind of getting kicked up. So, but try not to report tornado when you see something like this. Always try and verify what's happening above it, what's connecting to the cloud. And if there's nothing you can see that it gives you a clue that it's a funnel associated with that, then do not report tornado in this situation. All right, and those cold air funnels that we had in the quiz as well, but didn't have a question, but they can get pretty close to the ground. This one almost is halfway to the ground. They happen late spring, like right about now, early summer, and then also in the autumn or fall time frame. Usually there's no rain or even thunder out of situations where cold air funnels happen. It's basically there's cold air above the ground and then the air near the ground warms and it's rising rapidly enough that any tubes of air that are in the area get stretched and the funnel starts forming at cloud base level where the winds are accelerated enough to create that stretch. At the ground, the air is not rising as rapidly, so it's not stretching it enough to create a connection all the way to the ground. And cold air funnels almost never reach the ground. So there's usually not a damage type situation. We'll put a special weather statement out based on spotter reports of funnel clouds, and we'll figure it out that it's a cold air funnel kind of a day and not a tornado formation kind of a day, and so that everybody can see quickly on our website that it's not tornado type development. And we do not issue tornado warnings on those, obviously. All right. Any questions on spotter lookalike or funnel lookalikes, wall cloud lookalikes? Scud clouds are your enemy. Shadows are your enemy. So this part, now we're going to get into how you can prepare yourself for severe weather season, like right now. Our website is the main place to go, weather.gov/ILX or weather.gov/Lincoln. Take you to our website. Everybody has that as their homepage, right? Yes. All right. Seasonal is kind of the lead-in where you're preparing right now and getting that base training done. And the daily chances of probability of severe weather historically, April we start to see 3-4%, 5%, 6% chance in August. June and July are 6 to 7%. So of any particular day throughout the year, we have some chance. It's not zero. It's never a 0% chance because we have severe weather all year long. But even the peak times, 6% of any one day can possibly have severe weather. So climatologically speaking. But in terms of tornadoes, it's no contest. April, May, and June win that clearly. And we're heading into that season right now. That cold air from the winter and spring is starting to transition to the heat of the summer, and that transition zone is where a lot of rotation develops. The jet stream that's meandering more or less across Illinois at this particular point in time causes a lot of additional wind shear, and wherever that jet stream is and the little footballs of very fast air create extra lift at the ground and rotation. So, late May to early June, definitely the target zone there in terms of the most tornadoes, but anywhere from April through June is definitely peak season. 3 p.m. to 9 p.m. is your peak tornado time, so late afternoon into the early evening, even after dark. So 30% of all tornadoes are actually after the sun sets, which makes it really difficult to provide active spotter reports. But anything you can get before dusk settles in and you can't see a whole lot unless lightning is shining, flashing. Anything we can get, great, but obviously nighttime spotting is very dangerous because you can't get frequent information updates. All right, and in terms of hail and wind, the hail's in the pink here, the large hail peaks at April, May. The coldest air is usually in our area still about those times of the year. And then wind peaks in June or July. Oh, one thing I did want to point out on the tornadoes. There is a secondary bump in November, and that's not something that only is in Illinois. That's all across the country and in many of the high tornado producing states. There is a little secondary bump in November that, Washington Tornado Day, we actually had a couple of other severe weather days in a November time frame. But yeah, obviously every month of the year has had tornadoes, but November is kind of a secondary bump there. When you think things are winding down and Turkey Day coming, planning your feast, look out. So anyway, and then 2 to 11 p.m. is the peak severe time for hail and wind in general. So it's a little wider window, which you might imagine. Tornadoes are a little more selective in terms of how they develop and when they develop. And then lightning. We don't warn for lightning, but we are number 8 nationwide in terms of the lightning strikes, cloud to ground strikes per year. Obviously, Florida is number 1. Butterflies flap their wings in Florida and you get a thunderstorm, especially at 2 in the afternoon. So, boom, damn, monarchs are migrating again. So, number 8, there's a lot of lightning. Obviously, it can happen anywhere, anytime during any thunderstorm complex. So it's not severe triggers or anything. It's just something that you have to be aware of as a spotter. All right, preparing yourself. On our website, at the lower part, there's 4 columns, and one of them is observer info. And directly below that word is Skywarn Network. And that's where you would go for everything you want to see Skywarn or spotter related, everything on the sheet, and anything you want to do follow-up wise to this talk. There's even an old spotter talk in PDF form on there that you can just step through to see. A lot of the slides you're seeing today are similar slides, not exactly this. But that is where you go to just refresh your memory, because you're not going to remember everything. Actually, you remember about 10% of what you see in a, death by PowerPoint situation like this. So you're going to want to go back to the spotter page there, Skywarn Network, and just scroll down. It's kind of a long page because we have a lot on there, the spotter list and everything in terms of what, when we're giving spotter talks. But near the lower part of that page, there's a lot of refresher type courses. There actually is even a course on there. You can take a spotter class. There's 2 different versions of it on there where you step through an entire complex of slides. It's part of the COMET, C-O-M-E-T. There's a Meteorological Education and Training Center out in Boulder, Colorado that has a spotter class that you can actually take if you didn't happen to come to one. We hope everybody comes to a class like this, but that's also on there as well. But anyway, so that's preparing yourself and refreshing your memory after you forget everything from tonight. In terms of distance from your house or places you spot regularly, just kind of go to Google Maps and see where the tree line is. Is it 3 miles away or 4 miles away, and confirm what it is? Because a lot of times you guess twice as far. You think that's 4 miles away, and it's actually only about 2 miles away. Happened to me when a ship was coming by one day. But that's not that close, Captain. Come into my office, have a seat, close the door, thank you. What? Walk the plank? Come on, Captain. All right, so outlook and heads up is when we go to day 1 to day 5 kind of time range, where watches are possible, but we don't have them issued yet. But you start to go to the other side of the page, hazardous weather. And every day we issue something called a decision support slide deck or PowerPoint that has highly important information to severe weather potential. So if you click on that decision support link closer to events, or a couple 3 days ahead of time, we'll have what we call a decision support briefing, DSS, daily DSS briefing. We send that out to all emergency managers throughout our entire 35 county warning area, as well as other safety officials. And sometimes they'll fan that out to a lot of people within their own counties. So, but anyway, if you click on that DSS briefing, it'll pop into the main window, and you can go through all the slides that highlight what severe weather, what day, is it 2-3 days out, is it tomorrow, what kind of severe weather, are we looking at tornadoes or mainly flash flooding or whatever. But that particular slide deck for every spotter is kind of a good, just quick, what's going to be happening in the next few days. We also have a weather story, which is basically the most important weather item for that day, or the next most important thing, today or tomorrow, depending on what that is. And if you click on that, that's always on our main page as well. But this is on the Decision Support Services page, DSS page, weather.gov/Lincoln/DSS. And so much detail on there. And if you want to go further, you can go to the SPC if you want to really geek out on severe weather talk and buzzwords like vorticity, helicity, and everything you can't say without being drunk. It's all on that page. Anyway, so Storm Prediction Center produces these outlooks. Thunderstorms, marginal, general thunderstorm days in the light green, just you can have a few thunderstorms. If you start to see potential for a little bit of 40 to 60 mile an hour winds, maybe a couple of 1-inch hailstones, they'll throw a marginal swath in there. Things start ramping up in severity or potential for severity, slight risk. And you have 1 or 2 tornadoes, reports of strong wind damage will be spotty, isolated in nature, but they can happen. Enhanced means you're going to have a few more tornadoes, maybe 2 or 3 reported out of event, more persistent, intense thunderstorms, 1 to 2 inch hail. Once you see things ramp up to where it's going to be more of an outbreak type situation, then they'll go into the moderate risk, where you're going to have long-lived tornadoes potentially, and widespread wind damage, squall lines that cause what we call derecho type damage. And then high threat, where you're going to have basically a tornado outbreak with 20, 30 tornadoes, maybe even more, and some of those, 3, 4, or 5 of them could be EF4, EF5 level intensity. So the Washington Tornado Day was a high-risk day that day, and we had a lot of tornadoes. I think we had about 26 in Illinois, and 2 of them were EF4, and about 2 or 3 of them were EF3. So it was, and the studies show that every time we have a moderate or high risk, there is usually 1 death that occurs in Illinois, and about 30 injuries. So when we have a moderate or high risk, there's a life-threatening situation. It's on average, that's on average for any particular moderate or high risk day. And they usually only issue these about 7 to 10 times a year throughout the United States. So if you ever have a moderate or high risk, ramp up for a pretty busy day in terms of spotting. All right. And on that same DSS page, further down the list a little bit, we have hazardous weather outlook and other products as well. But hazardous weather outlook for a spotter is important because whatever county your group is in, and each county is listed, and there'll be multiple segments. And if you look for Champaign County and then look at the spotter information statement at the bottom, it'll tell you exactly when we think severe weather is going to affect your county that afternoon or evening. So that's a real important thing too. We tell you in multiple places. It's probably going to be in the slides that are available earlier that I mentioned, and also in this hazardous weather outlook. Once things start happening on a particular day, we'll give about a 4 to 6 hour heads up with watches. Storm Prediction Center will call us up, and they'll give us opportunity to actually add or decrease the size of the watch. Sometimes, when I first got into the Weather Service, you just sat there and waited for the watch to come blasting in and didn't have really a say in anything. But the last 5-6 years now, we've been kind of on a one-to-one basis with determining where and when watches are issued across our area, which helps keep us on our toes because we want to be able to provide quality feedback to the Storm Prediction Center when they call us up and say, what do you think? You want to go, I don't know, whatever you want. We want to talk meteorology and be ready to go. So everybody at work has got to be on their toes when severe weather's up and running or potentially going to start. And if you want more detailed information on any of the watches, SPC obviously puts in a little bit more detail than we go into for the spotters, but that's on their page, spc.noaa.gov. All right, once you get a situation where the watch is in your area, you want to just verify cell phone charged up, GPS device if it's not a cell phone. Weather radios got batteries ready to roll in case the warnings are issued for you, especially portable weather radios. They're a huge help. And obviously safe shelter plans and escape routes if you're mobile. Always know where you're going to be able to go for safety. Squall line situations in particular, because the whole squall line is probably going to blast through and you're not going to be able to have potential for a safe zone anyway. All right. Don't want to have a big construction project, remodeling in your home, and you can't get to your basement or whatever, or even your safe zone in the basement's all cluttered up. You want to make sure everything is prepared so that you can get there quickly without problems. In the Washington tornado day, there was a lot of video people were taking while their home was getting destroyed, and one of the guys said, as he was heading to his basement, the refrigerator hit him in the back as he was heading down the door. And I'm like, man, if your refrigerator beats you to the basement, here's your sign. Hello. I think I'm going to the basement. If you want to keep snapping photos and video, go right ahead, Sparky. So anyway, I just thought that was hilarious when he said that. Not hilarious. It actually was kind of scary because if your refrigerator's moving across the floor, there's some serious wind in your house. So he made it to safety and only had some minor cuts on his face. But mobile spotters definitely want to not go down any dead-end roads. You don't want to have adequate escape routes because tornadoes can develop and rotate and change direction quickly. All right, further up on that page, once we start see some storms producing damage, our local storm reports will be issued, and they'll say what time, what happened, what location, city and county, or distance from a city and a city in that county, and then who reported it, emergency manager, spotter, law enforcement, whatever that is. So clicking on that when storms are kind of upstream, just see what's happening, what's being reported, what are the spotters seeing, what should I look for. It's a good one. And then once the warnings are needed, our local office will have 8 to 10 people at our site. A few of them on radar, probably at least 1 or 2. One watching for tornadoes, another maybe looking for damaging wind and flooding. But tornado warnings, severe thunderstorm warning, and the severe weather statement. That kind of gets brushed under the rug a little bit, but the severe weather statement is the update for both the initial tornado warning and the initial severe thunderstorm warning. These do not get updated with updates. Everything that follows a tornado warning or a severe thunderstorm warning is always issued under the header Severe Weather Statement, SVS. It is the three-letter identifier. So always, and even cancellation. So if you think, is this tornado warning done? Yes or no? Severe weather statements will outline that for you. If you click on that, they'll all be listed, and you can just see which warning you're referring to. So, when do we issue a tornado warning? When we're really scared. No. 2 of the 3 conditions are met out of this list, and one of them, the first one is usually, is the environment capable of producing a tornado? Are there rotating tubes of air available today? Yes or no, and how are they going to be oriented? Are they going to be oriented in the same direction of motion of these storms? Because that'll ramp things up pretty quickly, depending on the storm motion. Because we determine from our balloon launches every day what is the direction of motion in this cloud-bearing layer, and that'll create the storm motion of whatever develops that day, at least initially. And then at the surface, there's going to be specific orientation of those tubes of air based on the air in the lowest 3,000 to 4,000 feet of the atmosphere. And if those 2 things line up, we know, look out. It's not always happening that way, but certainly when that's possible, we have condition 1 met and we're ready to roll. And then once we start getting the Doppler radar of persistent rotation, it isn't always needed. Sometimes we'll have 1 or 2 scans of rotation and a tornado will be on the ground and we'll be like, what? There's a tornado out of that? You know, but we get a spotter report, which is the 3rd one. If it's some trained spotter who reports it or public official. You know, 2 of these 3, and we usually get the tornado warning out the door really quick. Our software allows us to go from decision point to transmission in less than a minute. Sometimes, if you're really good at it and you know the threat zone is outlined pretty well by the software, you can get it out of the door in about 30 to 35 seconds. And we do that in training. We'll figure out, here's the situation. You're eventually going to need to be issuing a tornado warning at some point in this scenario, and then you know, our trainer will have there and he'll have a stopwatch, and we're supposed to announce when we, you know, what is our trigger point? Okay, I reached my trigger point. I'm going to issue a tornado warning. Click the software, get the thing set up, send, and then you'll, you know, stopwatch us and see how fast we can do it. And you don't want to do it rushed because you want to get a good score. You want to get everything right and train, you know, warn the people properly. But, you know, we can do it from decision to send in about 30 seconds if you're really good. In the past, we used to have to type out all our warnings. When I started, we had a radar person, and he'd put a ruler up to the radar. That's fine. It's 4 miles east of Champaign, moving. How fast is it moving? I don't know. Let me get a loop. I got a loop. Okay. 5 minutes of typing before we issued that warning. 5 minutes with a tornado on the ground. That's a lot of time, and it's you know, 30 seconds to a minute. We're pretty happy with that. Pretty happy with that. Studies have shown obviously not every rotation on radar produces a tornado. Only about in this 10 to 15% or so, and it's even less than that at times. 90% of those, however, do produce some type of damage. Wind damage, large hail, or a combination of both. So rotations on radar are, even if they don't produce a tornado, there's going to be probably some damage, 90% of the time, some wind damage at least. And hail if it's strong enough of an updraft. So there's always something to report out of a system, either something to report damage-wise or nothing happened. You know, even spotter reports that this went through and it's 40-mile-an-hour winds and a little light rain, and okay, now we know. Don't warn on that one. Don't get trapped in a dead-end road. You know, have someone to spot with you to lock the doors. Unlock the doors. Be aware of, you know, traffic congestion or construction areas or where it's difficult to get around. And obviously if police or law enforcement officials are in the process of handling the severe weather situation or whatever damage has occurred, steer clear of them if you are mobile. Know your position with respect to the movement of the storm. Where's the updraft? Where's the downdraft? You want the updraft on the left, the downdraft on the right for those supercell storms. And relative motion, no CBDR, constant bearing decreasing range. Always have motion left to right at least. And never drive through the core of a storm. If you're in a situation where you have like light rain, then really heavy rain, and some hail, combination of both, and all of a sudden the heavy rain starts to diminish and you have only hail falling, the hail falls closest to the updraft. 1 or 2 inch hail falling with no rain is kind of a dangerous situation, especially if all of a sudden everything stops and it's kind of calm. And actually that call zone between the rotating updraft and the downdraft and the hail stopping is actually a call zone. The winds are very weak, and then all of a sudden there's a tornado. Hello. And you could drive into either hail. That makes it very difficult to drive if you can't see. I haven't tried it, but that doesn't look fun. We had 4-inch hail blast through Tuscola, I don't know, 2 or 3 years ago. And it hailed like that for about 4 to 5 minutes, 3 to 4-inch hail. Take a softball and throw it at your windshield a few times and see what it looks like. So that's what was falling out of the sky. I mean, they don't reach terminal velocity when they're hitting the ground, but they're certainly, can cause a little bit of a headache if you're ever outside in that situation. Or you could drive into the tornado. We got cows. 1 or 2. Yeah, if you're punching the core of a storm, you could drive right into the tornado, literally. And we have at least one video of someone drove into the tornado. We've used it in the past. It isn't in this one, but here's somebody driving almost into the tornado. This is the Roanoke tornado day of 2004 when it destroyed the Parson plant. And this has some sound.
Oh, that's unbelievable.
He's driving almost toward it. If you put a little tick mark on his window, and then you drive it a little while, and you put another tick mark on his window.
We got debris flying everywhere. Look at that.
It is not moving. Now it's finally closer.
Wow, this is so unreal. I'm so close to it. There's more debris. Oh my goodness. This is crazy. I gotta get out of here. I'm going to turn parking lot here. Turn around. Look at all that stuff flying.
Look at it.
Everywhere.
That's-
We got a house set down.
Let's turn toward it.
Look at that.
Stop a while, open a
Church cemetery almost.
light beverage.
What? Wow. God, please help us not get smoked by that thing. Perfectly clear, and that thing's coming. It's going right at this house over here.
Look at all the debris. That is unbelievable. Yeah, here's your sign. And send us the video. 1362 State Route 10, National Weather Service, care of Ed. All right, yeah, it's not a good idea to drive anywhere towards a tornado. Obviously, if something's bearing down and you don't want to do that. All right, spotting at night, real fun. If you get enough lightning, you could possibly see something like this, and there's a little swirl at the ground. If you can pause your vision for a couple of seconds, you can possibly see what's going on there. But obviously, very dangerous situation, trying to spot at night. So you always want to basically be in your shelter looking towards what could potentially be a tornado development so that you're not caught off guard. All right, your safety is #1 priority, obviously. You don't report to us at the detriment of your safety. Always make sure you're not standing outside trying to call us, looking at the shadow. Make sure that shadow is clear of your building before you report it. Because when you're trying to, the adrenaline rush is there, you're staring at it, you want to get the most information, but don't be standing there videoing and whatever you're trying to do to get the information. Take safe shelter and then get us the information. Don't chase storms, don't drive into the tornado, things like that. So we don't encourage it. If you're obviously on your way to work because you have to, and you see things that as you're mobile, pull over and get the information that if there's something really severe potentially developing. But if you're mobile, great. But if not, stay clear of driving around. All spotters need to be alert to rapidly changing conditions. Tornadoes can develop right on top of you. All right, flooding. We want to cover that too because that's ramping up the list. It actually went ahead of tornadoes in terms of death production that have occurred in Illinois. The end of December 2015, we had a very heavy rainfall in southern half of Illinois, and about 12 people drove through flooded roads, and loss of life was way higher than it needed to be. So we have more flooding deaths now than tornado deaths in Illinois over the last 25 years or so. So it's kind of alarming people are driving around barricades, and it happens at night a lot of the time. You're like, I got to get home. I'm tired. I don't want to drive around. It's going to take me, 10, 15 more minutes, or sometimes longer, depending on where you live. But it's worth it because the loss of life in flooding is just so senseless. So you just basically, you only need about 18 inches of water, or enough to surf on. What? Who drives into that?
Yeah, he just made a mistake. There you go.
It's only splashing on the hood. What are you? Look how high it is on the signs. I mean, once the tires leave the road,
It's a company vehicle.
goodbye. And you're floating, 12 to 18 inches of water and you float, and that's 3 feet solid there. Luckily he got lodged, near a tree and it didn't flip over, but most of the time that is not something even a water rescue can help you with, depending on what's going on. So, wow. I can make it. I got a 4-wheel drive. Here's, hold my beer and watch this. Not gonna make it home in that situation. There's another road washout. This probably happened at night. You just, maybe a little bit of light, not light, but a water could have been 4 or 6 inches across the road where you couldn't see it, or maybe it was just too dark to see that the road was gone. You just never know. Little pockets of the road can get washed out when you may not actually be able to see it. So turn around, don't drown. That's our moniker, turn around, don't drown. Don't cross water-covered bridges. Bridges don't work well when the water is flowing over them. Those are for waterfalls. Doesn't work so well. Taking a nice stroll with your honey or significant other, whatever, bad idea. It's not a good idea because any culvert or drainage spot that sets up under this water, and there are going to be drainage spots, you just don't know where they are, especially if a culvert dislodges, because those things really draw water fast. You'll get sucked into the opening, and you basically, if it's deep enough, you won't be able to get out because the water is very, very strong when it's flowing quickly. All right, and lightning. Zap, boom. Luckily, cars are a nice, what we call a Faraday cage. The metal, it has nothing to do with the tires. You could be on a set of blocks, and the metal around the car will actually shroud you from the flow of electricity through the car. In theory. It's only 60,000 degrees Kelvin and about 1,000,000 volts. That trees don't like lightning. The sap immediately vaporizes, and the bark doesn't particularly appreciate that either. So trees explode. So if you're anywhere near a tree, not only do the roots energize, and you could possibly get electrocuted from the roots, you also can get injured from the bark exploding, another exploding tree there on the left side. Stay indoors, away from windows. This particular lightning strike was pretty close, and one particular gentleman didn't care for it. Boom! Yeah, real close. And it's not always striking the tallest object. There was a nice big bridge. Why didn't it strike the bridge? Obviously this guy's in a building taking some of this video here, but the tallest object doesn't always get struck first. So, if you're ever in a situation where you're outside and your hair starts standing up. Anybody ever been outside in a storm and your hair starts standing up? You are about to become the lightning rod. When a thunderstorm is building up charge, basically ice interaction in the thunderstorm as it's developing, the ice will hit each other and fragments. Small fragments float to the top of the storm as a positive charge, and larger ice fragments float to the bottom of the storm, or sink to the bottom of the storm as a negative charge. And that negative charge pools up at the bottom so strongly that the earth responds. And wherever this storm is moving across, all of a sudden the ground will have a lot of positive charges building up into the tallest objects. And if you are the tallest object, your head is the top of what those little charge balls or science balls that you stick your hand on. All the positive charges repel each other, and your hair is so light it stands up. So if you are feeling your hair stand up and there's a possible lightning situation, you're about to become a lightning rod. if there's nowhere to go inside at that point, you basically want to just keep your feet together to look like one object. So if the lightning does strike something nearby, you look like have an entry point in one foot and an exit point in the other, so the flow of electricity doesn't go through your heart. So keep your feet together and then crouch down. You do not want to lie down. If you're lying down, your head is one entry and your feet are the exit. So, put your head between your knees, kiss your butt goodbye. If you can reach that far. If you do yoga, you're fine. I would be in trouble because I can't get in that position very easily. So. Anyway, yeah, and there's a video we're going to show of a stepped leader, but stay inside of a building or a car, windows closed, and then if you hear thunder or see lightning, go indoors immediately and stay inside about 30 minutes. Trees are definitely dangerous, as we showed, and then outdoor buildings are all metal, not really the greatest, and if there's no walls. A golf course is bad, especially if you're swinging a metal object. Yeah. There's a lot of males. It's like it's about 60 to 70% males that get struck by lightning. But anyway, here's a stepped leader situation. So the cloud is sending out what we call a stepped leader, and these you can see because of the 70,000 frames per second. But this is usually not visible to the human eye, and all of a sudden the connection point is made, and the ground discharges up into the cloud. So the actual light that you see of lightning starts at the ground and discharges into the cloud. If we had it at an even higher, slower speed, I guess, you would actually see the image of light go from the ground to the cloud as the ground discharges and dissipates the overcharge of the cloud base. So it's pretty cool, but those stepped leaders are all over the place. The tallest object doesn't always get struck. So if you happen to be the tallest thing near the lowest stepped leader, you will become the lightning rod. So very dangerous situation. Anyway, so pretty cool. If you are in a car and you want to just pull over for safety, don't do it near a telephone pole or a tree. They fall over in strong winds and you can get a lot of damage. We've had many injury reports of cars falling on, or trees falling on cars, and the people were inside and get trapped. So just keep that in mind. If you're driving along, park your car parallel to the direction of motion of the wind.
This is cool, man.
This is cool. And here comes the downburst. The white, milky rain is getting blasted at them shortly.
Oh my goodness. It's here. Oh, wow.
Somebody driving right into it.
Why are they driving in that?
Let's roll down the window. Get a better look at that debris flying by.
Oh, yeah.
Yeah, it's all fun until a tree gets shredded and thrown. They got lucky. There was nothing really upstream of that downburst because they could have gotten pelted with a lot of damaging items picked up. But luckily, they didn't. If you're in your home, trees fall over into the upper floors, so try and get the lowest floors, if possible, away from windows. Tornado safety, they're shrouded by rain a lot, more often than we would like, but even a wedge tornado on the ground might just look like a big rain or wall of rain coming at you. That's been, obviously looking at your radar on your phone will help discern that, but lack of lightning or lighting or bad contrast can really shroud tornadoes sometimes. So always be aware. You may not even be able to see it as a spotter before it reaches you if you're not watching your radar. All right, and the debris is what's deadly. You want more walls between you and the debris, even if it's not in a basement. Get in an interior room, 3-4 walls, because that fridge took it on the chin right there. Maybe only one exterior wall between that kitchen and the outside. So that'd be a bad day if you weren't, inside or at the lowest level. And the cars are not really receptive to flying, you know, 2x4s either, nor is the curb, so debris flying around at 80 to 100, even higher, is deadly. So you want to get in a sturdy shelter, get down. Basement is you know, preferable, and cover up. Cover your head with whatever you can, because as debris flies around, if your home starts to get compromised and things start flying around, you want to cover your head with whatever you can, preferably, you know, something thicker. But you know, get in, get down, cover up. The key things. All right. Here's a tornado about ready to cross the interstate. This one's in Mississippi here, but
We don't know if this thing can change directions. We're not experts.
he's backing up on an interstate. He's really lucky nobody smashed into him.
It's crossing the interstate right where we were.
Yeah, they got pretty lucky. Yeah, that's pretty amazing. You don't want to do that. Backing up on an interstate either, but getting away from a tornado, you know. Last resort. Oops. Yeah, oops, we already played that. But last resort, if there's nowhere to go, no buildings, and you're in your car and a tornado is bearing down, the guidance is to get out of the car, because cars get picked up and just destroyed by tornadoes. They really do. You know, it doesn't matter if you have your seatbelt on, if they're landing on the roof or tumbled multiple times. There is loss of life potential there. The best thing, you know, in theory, is to get in a ditch. The debris will fly past you. The strongest winds will be above you, and you won't get picked up, you know, by the winds, because they'll be moving horizontally. But cars look like airplane wings. They lift. There's lift that's generated as wind flows over a car, just by the buoyancy effect of winds flowing faster over the top of the car than the bottom. So they do lift up and fly away, and it's not a good idea. So it's counterintuitive. I wouldn't be sitting in my car going, yeah, let's get out of this, baby. There's a tornado. But the ditch is the safest place. Cars don't survive very well. And if you're in it, it's you know, potential for loss of life is high. So your immediate threat is a tornado. I know people ask, what about the ditch flooding, or what about the lightning? Your immediate threat is that tornado and the debris that's throwing, or picking, you know, it's going to pick up, possibly your car. So the immediate threat is get out and go to the ditch. And then if lightning strikes you, boy, it was not your day. God put a little mark on the old column there that it's time to head home. So, yeah, just get out of
That's your mom's house.
For real?
The middle one, yes, my mom's house.
No way.
Yeah.
Wow. Yeah, we got this photo from a drone that was monitoring the.
I got the same picture on my phone.
Oh, too funny.
Yeah.
Wow.
The only thing that really happened is part of a tree came down on that north side.
Wow, that's amazing how close that came, and then the house is fine. Really, that's amazing. Yeah, I get a lot of stories like that where, you know, huge swath of damage, and all of a sudden, you know, the last house next to it didn't have hardly anything wrong. So, but don't keep the information you get during severe weather situations to yourself. Tell your emergency manager, get it to the office somehow. You know, especially during the situation of severe weather actually occurring, because if it spins, call it in is our moniker. Tornadoes, funnels, wall clouds. Anything spinning is a very important report. And multiple reports, not just once. If you have any kind of tornadic development report, always have a follow-up call of, I can't see it anymore, or it dissipated right in front of me. Something that closes off the beginning of what you just reported, no matter what it is, you know. So never have, if it spins, call it in moment. Have a second call of, this is what has occurred or ended, or, you know, whatever. Because we're sitting at the radar and we get that initial report and we're like, okay, tick tock. It's still spinning like a top on radar, but is it really on the ground anymore? You know, is it just a wall cloud now because of, you know, just dissipated? So it's great to give us that extra step. It's very helpful. And then flooding, any flooding at all, obviously with the amount of loss of life flooding lately. And then any wind damage at all. 50 to 60 mile an hour winds will start to cause 3-inch branches to fall, get ripped from trees. But any wind damage at all, report it. And then hailstones, any hailstones really. Even if it's just pea size, it'll gauge the radar for any particular day. But you know, 1-inch hail is our trigger for a severe thunderstorm warning. If you don't have any rulers or anything, the adult hand, each segment of your finger is about 1 inch. So the poor man's ruler, you just lay it in your hand and see how big it is. A lot of people have been snapping photos with their phone and tweeting it to us. If you use hashtag ILWX, Illinois weather, ILWX, we're monitoring Twitter all the time too, so or post it to Facebook or whatever. But having photos with the hail reports are really, really helpful to gauge what's actually the size of the hail. All right, and if you're reporting, the first thing to have out of your mouth is, I am a trained spotter. If it's to the EMA or if it happens to be to the office, I am a trained spotter. First thing out of your mouth. What you have witnessed. You know, what happened? The hail, it's on the ground, it's probably been on the ground 20 minutes, it's still 1.5 inches or whatever. Or I'm watching a tornado development. You know, whatever you've got in front of you, if you're on the phone during the event, that's huge. You know, as fast as you can get severe weather information to us, the best. But when the event occurred, if it's not now, we can gauge it off of radar if you don't know. If you're walking onto damage or coming up upon damage that you don't know when it happened, just let us know where it is and what it is, and then we'll discern when it occurred on a radar loop. And then where. To the best of your ability, well-known roads are cool in terms of where you are and which direction you're looking if you're actually seeing something at the time. Distance from a city if you know, but you know, the best you can to where an event occurred in relation to major roads or cities. All right, so those things are all in the sheet that you have in terms of reporting, but if you're part of the EMA reporting network, definitely do that. Call them and they'll relay it to us. If you have no other, you know, every phone is busy and you want to get the information in, it's very important. You can dial 911 or the law enforcement agency and they will relay it as well and get it to the office. And then if you're a Skywarn spotter not associated with an EMA, you know, you can report directly to us. Obviously, if someone is injured, call 911 and take care of anything health, you know, health related. If someone's potentially going to, you know, have a loss of life or an injury, call 911 and take care of that. Then later on, you can report it, whatever you had to report, to the National Weather Service. And we have all different ways. You know, we have an email called ilxspotter@noaa.gov. We monitor that continuously during severe weather. Facebook, we're NWS Lincoln. Twitter, we're at NWS Lincoln. And then using the hashtag ILWX. MPing is another thing that we can see reports of different precipitation falling down. But in terms of severe weather, you know, calling us or getting it to us any way you can. Social media is definitely monitored now. Someone is dedicated to social media at our office to try and get reports. All right. And state, once again, that you are a trained spotter or Skywarn spotter. And social media, as I mentioned. If you come upon something days later even, you know, just let us know even. We'll figure out whether it was part of that event or not based on where it occurred, more than likely. Don't think that somebody probably already reported this great big tree down. Not always the case. So report anything you see that might be correlated with severe weather, and we'll take that information and put it in the database and figure out what it was all about. All right, if you're not an EMA or ESDA volunteer and you want to be a new Skywarn spotter, in our system, on our website, on that spotter page near the bottom, there's a Skywarn symbol, which is basically like a tornado in black and orange. If you click on that Skywarn symbol in the lower part of our page, you can register with you know, information. You'll click on it. I have paper sheets if you have no way to get on the internet to do this, but if you want to be a Skywarn spotter, you can click on whatever spotter talk you went to and then just put in some basic contact information, and that's on our website on that spotter page that I showed you at the beginning of the class, which is also on your sheet here too. So, but that's one way you can you know, be registered at our office if you're not already an EMA volunteer. And it's weather.gov/Lincoln, and if you don't want to go to our website and click around, you can just put this directly into your browser, spotter, hashtag, criteria, and that'll take you to this registration form. All right. You must be at least 18 to be officially a spotter, but you know, any kids that are involved, you know, if you can help your family out, you know, obviously don't go out there and do things like my son probably would. Dad, a tornado, I think. Let's run outside, you know. Anyway, 18 years of age officially. All right, and COCO-RAS, Community Collaborative Rain, Hail, and Snow Network. We're kind of promoting that as much as we can. because it's not necessarily severe weather oriented, but it's rain, hail, snow network, and it provides a lot of information to our office, especially in heavy rain events. And there's a way to report immediately on heavy rain situations. But if anybody, is anybody already in the network? We have quite a wide range. Yeah, Steve Hilberg here, he's our coordinator for, is it all of Illinois or?
Yeah.
All of Illinois. And the training goes on periodically on how to do this, but you get a 4-inch rain gauge, excuse me, and you help us out. You measure the rain, you call it in, and then we use it to plot exactly what occurs. And it's a really huge benefit to our office, because I'll go on there in the morning and see what happened all across the area, and a lot of places that don't have an airport or any other way to get the information. And you just need to go, you go to the website, cocorahs.org, cocoras.org, and you eventually obtain 4-inch rain gauge by ordering one. WeatherYourWay.com, which is an old National Weather Service employee. She has a lot of those 4-inch rain gauges for the best price. But anyway, so then you do the slide show of training or attend a training session, and then you get a gauge in good location in your yard as well. You don't want to have a lot of trees blocking your gauge, and then start observing the precip and reporting daily. So it's a huge help to us, not only on the severe weather side, but just in general weather help. So.
I'll be around afterwards if anybody has.
Oh, yeah, Steve will hang around if you have any questions on that. Because flash flooding events are driven off of how much rain has already fallen a lot of times. And if we get a really good map of what fell where, we can give that to the River Forecast, or the National Weather Service out in Washington, the WPC, and they put out outlooks for flash flood potential. So if we have a really good picture of what fell when, your community could be ramped up into the outlook phase of flash flooding. So it's a really good help in all senses. Anyway, all right, a few final words. Obviously, I've beaten this to death probably, but safety is number one. Always know where you want to go for safe shelter, especially before the event starts occurring. And then, you are a vital part of our process for warnings. You help your community that you're in and everybody downstream. It just saves lives, it does. Especially on that Washington tornado day. I mean, we only had one loss of life during that EF4 tornado, which was absolutely amazing, because Joplin had about 163 deaths. But that was on a different kind of day. There was a warning and then another warning, and there was some confusion on whether it was a real warning for this old tornado or a new one. But 163 versus 1 on EF4 tornado day. We had a huge success that day in terms of loss of life or potential loss of life, and that was driven by spotter reports giving us excellent information. So people don't take shelter unless they know something's happening, and that's just the case. So we need your reports. Obviously a lot of stuff thrown at you today. Go back to that website later on so that the 10% memory goes up to 12, maybe 13%. Just review it a little bit. If you can't come every year, every 2 years is pretty good, but it's always good to get this refresher training every year. And then weather.gov/ILX spotter, that's that page to just go for all the information you ever wanted to know about spotting. And then we have a YouTube page as well that has all the videos. We did have someone record stepping through the slides and saying everything kind of I'm saying. So we have YouTube, about 8 or 9 different segments of 5-6 minutes doing what I'm doing here, just going over slides. So you can do that too on the website. All right, thanks for coming everybody. Be safe out there.